Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. In today's class, we are going to have the topic matrix eigenvalue problems. In that case, we are going to solve one case study which is based on eigenvalue and eigenvector. Here we are going to unlock the hidden dynamics of any complex system. If we want to find the stability of any system, we can use eigenvalue and eigenvector. So the first thing is we should know the basic terminologies and what is the meaning, right? Those things are to know, right? So the first thing is eigenvalues. So it is the scalar value which is going to represent the scaling factor by which an eigenvector is stretched or shrunk during a linear transformation, and there it is going to reveal the insights into the growth, decay or stability. And the next thing is eigenvector. So it should be a non-zero vector and it should remain in the same direction after a linear transformation, which is scaled by the corresponding eigenvalue, and it is going to identify the principal directions of change, and together they form the fundamental building blocks for understanding the linear transformations, which is crucial in fields from physics to data science. The next thing is we are going to setting the stage, the problem of complex systems. In many real world systems, from financial markets to structural engineering, which is going to involve the interdependencies, and it is going to analyze their behavior, which is going to be overwhelming. And there are three things I want to remember: interconnectedness. So it is the system with numerous interacting variables. And the second thing is dynamic behavior, changes over the time due to internal and external forces. And the third thing is predictive challenge, which is the difficulty in forecasting the future states or identifying the vulnerabilities. Okay, the next thing is growth factor. So eigenvalue, which is going to indicate the rapid expansion, and the decay factor is it shows a reduction over the time. And the next thing is stability point. So it is going to represent a stable equilibrium. And the next thing is the power of eigenvalues, understanding the system growth and the decay. So the eigenvalues quantify the rate at which system components grow or decay. The value which is greater than 1 signifies growth, less than 1 indicates decay, and exactly 1 implies stability. And the next thing is we are going to see the direction of eigenvectors, identifying the principal components, the eigenvectors which reveal the fundamental directions along which a system, and they act as an axis. And the next thing is we are going to have this case. Okay, the case is what? We are going to analyze the structural stability. Okay. So we applied eigen analysis to a bridge structure to access its stability under various load conditions. Okay, so under various load conditions we are going to have the stability. We are going to check the stability, and the goal was to identify the potential failure modes and the critical stress points. Okay, so these are the goals we need to achieve. Okay, the first goal is load simulation. So for this we need to apply the various traffic and wind loads, and the second thing is we are going to analyze. So the second one is eigen analysis. For that we need to calculate the eigenvalues and eigenvectors of the system matrix. And the next thing is the results and insights. So for this we need to predict the system behavior with eigenvalues. Okay, so there are three things to keep it in your mind. The first thing is critical frequencies. Okay, so we need to identify the critical frequency, and we need to have stress concentrations, and the third one is predictive maintenance. Okay, so in critical frequencies, identify the vibrational modes corresponding to potential resonance issues, and in stress concentrations, pinpointed areas under extreme load, which is going to confirm the design strengths and weaknesses. And the third thing is predictive maintenance, which is allowed for proactive reinforcement of vulnerable sections. And the next thing is okay, so what are the key which is we are taking from this, and what are the future horizons in this case? Okay, those things are to have. Okay, so the first thing is it should be a powerful tool. So eigen analysis is essential for understanding the linear systems, and the second one is diverse applications from engineering to quantum mechanics and the data science. And in the third case, which is the real world impact, which is the most important, it is going to predict the behavior and optimizing the designs and enhancing the safety. Okay, so these are the things you have to remember in your mind. Okay, so in today's class we just have a thought about eigenvalue, eigenvector, and how it is implemented, right? And what is the case based on that. Those things we saw in today's class. Okay, thank you. We will see you in the next class.